Okay, today we are covering section 6.1. So we are going to be looking at sequences. And if you missed class, you can follow along here. This is directly from your textbook. And if you didn't understand it in class, this is a great resource for you to listen again. So I did give you some notes for this section. If you weren't in class, you can get those on Google Classroom. I'll post a link. And that would be, the best resource for you. So today we're going to be talking about the difference between arithmetic sequence and a geometric sequence. So an arithmetic sequence is when you have consecutive terms that have a common difference. So that means you're going to be subtracting and you're going to look for this common difference. Now you're looking at consecutive terms, which mean they come directly after the one before it. And then a geometric sequence is a sequence of terms in which the ratio is common. Okay, so that means we're dividing. So sequences can have a fixed number of terms, which means that that would be a finite sequence. And if a sequence continues forever, we consider that an infinite sequence. So if you look at Lisa and Ray here, the first terms are 1, 1, 1, and we're trying to figure out, Lisa says the next set of terms would be 2, 2, 2, then 3, 3, 3. And Ray is saying that the sequence would just repeat 1 forever. And so, who is correct? Well, the long and short of this is they both are. Sometimes we are not given enough information with this original set that we can decide if what's actually happening. So 2, 2, 2, 3, 3, 3, that could happen, and Ray with a 1, 1, 1, 1, 1 and continuing forever, that could also happen. So sometimes you need more information to decide, and all we can say is they both could be correct or they both could be wrong. We don't know. So let's move on. Looking at this next one, we want to analyze each sequence and then circle the appropriate type of sequence. If the sequence is arithmetic, identify the common difference, and if the sequence is geometric, identify the common ratio. Finally, circle whether the sequence is infinite or finite. And so the very first thing you need to do is count these number of tiles. So go ahead and do that. Okay, so looking at these numbers, we've got 9 tiles in our first, then 12 in our second, and 15 in the third figure, and 18 in the fourth figure. So what is happening between each figure? Well, we can determine if it's an arithmetic or geometric sequence by finding if there's a common difference or finding if there's a common ratio. So 12 minus 9 is 3. And 15 minus 12 is 3. And 18 minus 15 is 3. So if you see that I'm looking at the consecutive boxes or figures, then you would just subtract the second term from the first term, first term from the second term, and the second term from the third term, and the third term from the fourth term, and figure out, do you have a common difference? And here you can see you do have a common difference. The common difference is 3, so we would say D equals 3, and it's an arithmetic sequence. And technically, this can continue on forever. So we would say that it's infinite. This could go on and on forever. So, looking at the number of toothpicks, very first step, go ahead and write down the number of toothpicks in each one of these figures. Okay, so in my first figure I have 12 toothpicks. In my second, with that next row on top, I would have 22 toothpicks, and then I would have 30 toothpicks in my next one. So, do we have a common difference or do we have a common ratio? That's what we're asking ourselves. So first we can see that 22 minus 12 is 10, and 30 minus 22 is 8. So we know it's not arithmetic. That's not a possibility. So now let's check for the common ratio. Again, you're going to use your second term divided by your first term. And here, this just reduces down to 11/6. And then if we look at 30 divided by 22, this reduces down to 15/11ths. There's not a common ratio because these numbers are not the same. So it's not a geometric sequence either. So we would say this is neither. Now, this is eventually going to end. So we would consider this a finite sequence. When it gets to the very top, you can't continue adding. So we would say it's finite. Next one, go ahead and look. We are looking for the number of rows here. So just write down the number of rows. Here, I've got 1 row, 2 rows, 3 rows, 4 rows. So is this arithmetic or is this geometric? Well, do I have a common difference? 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. And since I have a common difference, I would say my difference is 1 and that this is arithmetic. Now, could I continue adding rows forever and ever? Well, technically I could. So we would say that it's infinite. I hope this is helping. Go ahead and try that next page and so hit pause, try the next page, and then come back and check your answers. Okay, so number of cubes. In my first figure I have 1, then 6, then 18, then 40. So if I start the subtraction, 6 minus 1 is 5, 18 minus 6 is 12. Since those are not common differences, it's not an arithmetic sequence. Now, 6 divided by 1 is 6. 18 divided by 6 is 3. Right away I know that this is not in a geometric sequence because my ratio is not the same. So I would say that it's neither, and technically this could go on forever, so this would be considered an infinite sequence. Next 2 problems, number of black triangles. In my first figure I have 3, my second 9, my third 27, my fourth 81. I can look at this right away and see that I don't have a common difference, so I know it's not an arithmetic sequence, but do I have a common ratio? So 9 divided by 3 is 3. 27 divided by 9 is 3. 81 divided by 27 is 3. So because I have a common ratio here, I have a geometric sequence, and my ratio is 3. Okay. Again, this could go on and on forever, and I would have some very tiny little white triangles, but black triangles, but it could technically go on. And then number of white triangles. My first figure I have 1, my second 4, my third 13, and my fourth 40. And if I look at this, 4 minus 1 is 3, 13 minus 4 is 9. Since I don't have a common difference, I know it's not an arithmetic sequence. Here, 4 divided by 1 is 4, 13 divided by 4 is 13/4. So right away I know, since I don't have a common ratio, it's not a geometric sequence. So this would be considered neither. Now, technically, this could continue happening, so I would consider this an infinite sequence. Okay, side length of the smallest shaded square within the unit square. So a unit square means that each side has a side length of 1. So this first one, a half, the shaded square would be 1/2 in side length. And then my next one, I would have 1/4. This is 1/4 or 1/2 of 1/2. And then this third one would be 1/8 or 1/2 of 1/4. And then this last one would be 1/16 or 1/2 of 1/8. Now, is this arithmetic or is this geometric? We have to do some work to figure that out. It's everybody's favorite, looking at fractions. So the first thing we're going to check is this arithmetic? Do they have a common difference? And then we're going to look at, do they have a common ratio? Okay, looking at my common difference here, or trying to determine, do I have a common difference? If I subtract 1/2 from 1/4, I need to first get common denominators. So my common denominator here would be a 4, and 1/2 is the same as 2/4. So 1/4 minus 2/4 is a negative 1/4. So I need to try the next two terms. 1/8 minus 1/4. Again, we need common denominators. Common denominator here would be an 8, so 1/8 minus 2/8 is equal to negative 1/8. So I have a difference of negative 1/4 with my first two terms and a difference of negative 1/8 with terms 2 and 3. So I know that this is not an arithmetic sequence. So let's try ratios. I'm going to move this over and we're going to do ratios over here. Okay, so if I look at my first two terms, I'm going to divide my second term by my first term. So I have 1/4 divided by 1/2. And when we divide fractions, we change division to multiplication, and we multiply by the reciprocal of our second fraction. So I have 1/4 times 2 over 1. If I multiply straight across, 1 times 2 is 2, 4 times 1 is 4. This can be reduced to 1/2. Now, I need to try that with my terms 2 and terms 3. So I have 1/8 divided by 1/4. I would rewrite 1/8, change division to multiplication, and then take the reciprocal of my second fraction. So that would make 1/4 4 over 1. And now again, 1 times 4 is 4, 8 times 1 is 8. This can be reduced to 1/2. So I can see I have a common ratio. My common ratio is R equals 1/2. Okay, so if I have a common ratio, that means I have a geometric sequence. And can this pattern continue forever? Technically, yes. It's infinite. Okay, number of shaded squares. What's happening each time? We're not going to spend much time on this. Here you can see that you've got 1 shaded, and this one 2 shaded. So 1 shaded, 2 shaded, 3 shaded, 4 shaded. Hopefully you can easily see that this is increasing by 1 each time. So it would be an arithmetic sequence. The difference would be 1, and again this would be infinite. So creating your own sequence given the type indicated. Now, the difference between a finite series sequence and an infinite sequence is simply an infinite sequence has these 3 little dots. Oh, and we're not even there yet, so delete what I just said. Okay, in arithmetic sequence, you have a common difference. A geometric sequence, you have a common ratio, and neither an arithmetic or geometric sequence, that means you have something happening that's considered a sequence, but it's not either a common difference or a common ratio. So an arithmetic sequence, something easy, would be 2, 4, 6, 8. And the difference between a finite series and an infinite series, this would be considered finite, and infinite would simply have these 3 little dots at the end. Those are called ellipses. So a geometric sequence, so this one, our difference is 2. Now, if we want to look at common ratio, we could say 2, 4, 8, 16. Now, this would be considered a finite series because it simply ends at 16. If we wanted an infinite, we could say 2, 4, 8, 16, and so on, the ellipses. And again, this would be considered geometric because you've got a ratio of 2 here. That means between 4 divided by 2 is 2, and 8 divided by 4 is 2, and 16 divided by 8 is 2. So neither arithmetic or geometric. You can just pick something. You could simply do 1, 1, 1, 1, and so on. Or 1, 1, 1, 2, 2, 2, 3, 3, 3. Those are both neither arithmetic. Actually, that top one might be because you could have a difference of 0. But, yeah, there we go. Sorry.